Hello and welcome back to Multibiomics, and we are continuing our series of Computational Genomics in R, and the book that we are following is by the same title, Computational Genomics in R by Altuna Akalin, and I'll be pasting the link in the description box and you can just go through that. And so we are moving on to the next topic, plotting with Bayes graphs. So base graphs are the basic, some options that R is giving us to plot a few different types of graphs to visualize our data. And in today's video, we'll be looking at histograms. Okay, so let us start coding now. So for plotting now, we will generate data. So for data generation, now computers they need numbers to generate data. Okay, fine. So to plot, we give it, and just now because we are going through some exercise and examples, let us generate our own data. Now what we are thinking is to generate some random numbers. Okay. But the problem with generating random number is that computers often use pseudo random number generators, also known as PRNGs. So in a sense, they're not truly random. They generate numbers based on a starting point, and this starting point is known as seed. So if you have a same seed each time when you run the code or you run your model, the same sequence of random numbers are generated. But if you don't set a seed every time, then you'll get different seeds, different starting point, and you'll get different set of random numbers, and you'll get different results. So reproducibility cannot be achieved. If you run your code today and if you run your code tomorrow without seed, you'll get different results. And this is very critical, in research papers and ML experiments and in, various bioinformatics pipeline. So for that, what we are doing is we are setting seed, set.seed. You can set any number. I'm starting set seed 42. This is my personal, habit of setting seed at 42. Yeah, and then now we will generate some sample data. At any point, if you feel that my video is slow, you can just amp it up at 1.5x speed, right? So now for generating sample data, so we are generating we'll be generating some random numbers and we'll be storing it in X, and for that we are using R norm. So R norm will create random numbers, but all those numbers will be distributed normally. I want 50 random numbers, so I'm giving the number as 50. If I want to set mean, the mean is equal to 1, 2, 0, whatever. So what does this mean? So for that, we'll be, going deep into statistics. So mean is one of the central tendency, and this random distribution is, distributed centrally around the mean zero value. Okay. If you put mean is equal to 1, what will happen? The whole distribution will slightly shift towards 1, 2, etc. Right? So these are something that we are not going to discuss right now. We are generating another set of random numbers and we are storing that in Y. So same command we are going to use, R norm. And again, we are going to generate the same 50 set of random numbers. So we'll just run these commands. So for running, you select all and click on run, or what you can do is you press control and then enter. And you can see in your R global environment, X and Y values, it will be shown over here, right? So now let us start by plotting our histogram. Here, now we'll be starting with plotting the histogram, and the command that we are using is hist command. So after hist, you have to open it with the parentheses, and we'll be writing certain arguments, and that will shape our bar plot. Sorry, the histogram plot. Okay. So I want the plot for the data that has been stored in X, and I'll just close the parentheses. And for running, Control Enter, you can see a simple histogram of the values of X has been generated. Now, if you want to customize, your bar plot, you can do that also. So to add a new argument, you have to, put a comma and then you can add any other new argument. So if you want to place a title, so For that, we are using main argument. Main equals, if I want the heading as, customized histogram, you can do that and close the parentheses. But if you want some other argument, like, yep, so you put a comma and then you can change the color, whatever color you want. Color equals, inside the quotes you write, I want the color as maybe just try yellow this time. And then comma, then okay, comma after the quotes. What kind of border do you want? Border equals black. Okay, you can do that. I want to name the labels like, so what should be the x-axis named as? For that, you'll use xlab equals. So xlab, let us put time. So x-axis is the time axis, and ylab, let it be the, number of colonies or number of cells, whatever you want. Then another thing that I want to tell you is breaks arguments. The breaks will introduce, a range. It will break your whole data into a certain range. If I put breaks equals 10, so your the data is distributed into 10 different ranges, and the number of bars that you'll be getting will be 11. It will be always one more than the break number that you have set. Okay, so this is the last argument break, and I am not using any argument apart from this. There's no need to put a comma at the end, and then just close with the parentheses and control enter. Lab, comma, ylab. Okay, so here is the mistake, equals, right? So you can go back and you can check whether your syntax is correct or not. And then if I enter, yeah, it has. Okay, so we have got this customized histogram. Then you can see I have to scroll. Okay, the readability is not so good. So there's another way of writing. So each argument after the comma, what you can do, you can press enter. It will follow the indentation. It will just come below the previous argument. And you can write in this manner also. Also a way that you can write your, I'm selecting everything. Again, I'm running this. So I do not expect any changes. Done. I'm getting the same graph. Now I'm adding a probability density curve over it. Okay. So if you don't know what is probability density curve, you can go and check out this is these are basic statistics that you can go and check. I'll also try to put a video on what is a probability density curve, right? Let us plot a probability density curve on top of our histogram, and for that we are going to introduce a line, a curved line. For that, the command is lines, and we want a density curve, right? So density will write, and the values should be of x, and suppose line width to be make line width LWD. LWD is line width equals, I'm putting the value as 3. Now if I'm running this, you can see a curved line has come over here, but this is not so readable, not so clear. If I add this argument like probability equals, the value should be true, and I will run this again, enter. Okay, so the mistake that I've committed is no comma. So after each argument, if it's not the last argument, you have to add comma. Control enter. So now you can see the y labels have changed. Sorry, not the y labels, the y values have changed. And now if I'm plotting this density curve, clearly it's visible. We can also we can also visualize where our mean lies. Okay. So mean. So for that, what we are doing is, okay, plotting the mean line. Okay. So in the same graph, what we'll do is we'll make again, for that should write AB line. Okay. AB line. Okay, AB line. That is the this is the way you can visualize a certain point where that particular point lies. You know, for x-axis, you have to draw a vertical line, and for the y-axis, you have to draw a horizontal line. So since we want the mean, where the mean lies, we want to see that. We have to draw a vertical line over here, so we can write as v. Okay. So what does v means? A vertical line. And where will the v lie? That is the vertical line. It will be, it will be lying on the mean value of x. The way you have to write it. Okay. Let the color of the line be red. Okay. For better visibility, let the line width be, let us have 2. Control enter. Yeah. So your mean lies somewhere near, 0. Let's see where the median lies. Yeah. See, we have plotted. So median, let us as blue. Yeah. So median and mean. So these are the two types of central tendency. They are slightly, you know, shifted, slightly shifted, right? So that was a very easy hands-on tutorial on how to plot your histograms, and how to customize it, color it, and how to plot a probability density curve over it, how to find where the median or the mean lies, right? So there are other plots in this series also, so we'll be dropping those videos soon. Please consider liking this video and subscribing to the channel. Also, I want to tell you that if you want to download the code, the script, you can go to the Google Classroom. The link is provided below in the description box or in the comment. I'll just pin it. And yeah, you can also join my WhatsApp group where I'll be posting the computational genomics video slowly and steadily. Thank you.